Hi, in this session we will develop a model using support vector machine that correctly identifies the handwritten digits based on the pixel values as features. So we load the required libraries and the dataset and do the basic checks for the missing values. So once this is done, we will check for any zero variance present in the columns across the dataset. So the reason why we need to do is that if you look at the dataset, there are a lot of columns which have majority of the values as zeros. So what this means is that if there is no variation in the values in a particular column and it is dominated by single variable, so it may not significantly impact the model, and therefore we can get rid of those. And this is what we do using the near zero var function in R. So once this is done, we will split the entire dataset into the testing and the training datasets. So we use 15% as a threshold So since it's a huge dataset, so we believe that 15% of the dataset would be a good good amount of data to build a model. So let the zero variance be computed. Yeah, so it's done, and then we split the data, and then we build the model using the SVM function. And the kernel that we use is a linear kernel as signified by the vanilla dot. So once the model is built, we do the prediction and build the confusion matrix to check the accuracy of this model. Once this is done, we see that the accuracy is around 88%. We would like to try a different kernel, a radial basis kernel, using the RBF dot as a using kernel hyperparameter value as RBF dot. So since the data set is huge, so this is computationally very time extensive, and so we see that once it gets completed, the accuracy that we get is 95%. And when we do the same operation using the polynomial function as signified by the polydot kernel hyperparameter, we see that the accuracy is 80%. So the RBF kernel in this case seems to be a better choice when compared to polynomial and the linear kernels. And once so then we try to do some cross validation and try to figure out the sigma and the c values for the radial basis kernel. And since all this are very time expensive, so we will not be able to wait that long, but when we do the cross validation, we see that the sigma is 0.01 and c equal to 5, which gives us the accuracy of 95.6%, which basically means that there's not too much of non-linearity. The sigma 0.01 means that there's not too much of non-linearity in the radial basis kernel, and with c equal to 5 we have a pretty good accuracy. So therefore we stop here and we complete the analysis. Thank you very much.